Hello everyone, today we're going to look at the derivative of exponential functions. So an exponential looks like b to the x, and if we differentiate it, we get b to the x, so itself, times the natural log of b. If you want to look at the workings behind this, why it is what it is, feel free to read through the book, but we're just going to show this is what it is, trust me for now. More generally, we're going to look at the derivative of b to the u, where u is some function of x. So something like b to the x squared, b to the sine of x, b to the x cubed minus 2x. So we need to use a chain rule. So we have b to the u, again the original function, times ln of b times du dx. So don't forget that the chain rule, you have to multiply everything by the derivative of u, by the derivative of that inside function. However, the base that we typically use is e. So we're going to deal with the derivative, and that should be in parentheses, of e to the u. And the really nice thing about when b is e is that ln of b becomes ln of e, which is just 1. Remember that ln is log base e, and this is saying e to what power is e, and that's 1. So I just have e to the u times du dx, and I don't need the ln of e because, again, that's just 1. So this is the one we're going to focus on. 98% of these are going to be e to a power. So we'll do a couple examples. So a is y equals e to the x cubed. So in order to differentiate it, we're going to start with the function itself, e to the x cubed, and then multiply it by the derivative of x cubed. So we have 3x squared, e to the x cubed. For our next one, we have sine of e to the x. So this isn't e to a function, it's sine of a function. So we have to remember how to differentiate sine of something. And the derivative of sine is cosine. So we're going to end up with cosine of e to the x times the derivative of our inside function, which is e to the x times 1. So we just have cosine of e to the x times e to the x. For our third one, we have y equals 5 to the 3x minus 2. So our base is 5 instead of e. So when we differentiate it, we have something extra to it. But again, we start with the exact same function. So 5 to the power of 3x minus 2. And then we multiply it by the derivative of our inside function. So the derivative of this guy, which is 3. And then lastly, since our base is not e, we need to multiply it by ln of our base, so ln of 5. We can clean this up a little bit. If we remember rules of exponents, this 3 can come in as an exponent, sorry, our rules of logs. The 3 comes in as an exponent, so we have ln of 125 instead of 3 times ln of 5. So here's another one, y equals ln of x times e to the 2x. So again, we need to remember how to differentiate ln of x. So we have a product here, so we need the product rule. We start with the derivative of our first function. Remember, the derivative of ln of x is 1 over x times our second function. So 1 over x times e to the 2x. And then we're going to add to it the derivative of our second function, which will be itself, e to the 2x, times the derivative of our exponent, which is 2, and then we multiply it again by our original function. So we have plus 2 e to the 2x ln of x. Here's another one, y equals e to the x divided by x. So we have a quotient here. I could, if I wanted to, rewrite this as e to the x times x to the negative 1 and make it a product rule instead. But just for practice, I'm going to keep it as the quotient rule. So remember, the quotient rule starts with the derivative of the top function times the bottom function. And the really nice thing about e to the x is it is its own derivative. So the derivative of e to the x is e to the x. So we start with e to the x times x, and u prime times v, minus v prime times u. V prime, the derivative of the bottom, is 1, and then u is e to the x. So I have a plus here, but that should be a minus. So e to the x times x minus e to the x, and then it gets divided by the bottom square. So again, just remember that should be a negative. So e to the x, x minus e to the x all over x squared. And it's going to stay a plus because that's just how it happens. So just remember that plus should be a negative. So for f, our last one, we have y equals e to the cosine of 3x. So we're going to start with, again, the function itself, e to the cosine of 3x, and then we multiply it by the derivative of our exponent. The derivative of cosine, remember, is negative sine. So we have negative sine of 3x, and then we have to keep going because this is really a composition within a composition, and we still have this 3x to deal with. So we still need to multiply by the derivative of 3x, which is 3. Make sure that if you're writing it this way, you have these parentheses, because otherwise it's going to be e to the cosine 3x minus sine of 3x. So remember that this is a negative sign, not a minus sign. You need it in parentheses because you're multiplying it all. And then we'll clean it up. You always put your coefficients out front, including a negative sign. So negative 3 sine of 3x times e to the cosine 3x. So read through the book, try the homework, and let me know if you have any questions. Good luck.